Okay, so we should be live on all platforms. So just to everyone who joins, this is actually our first ever webinar for WireMock. We are testing the new platform, and yeah, we are spinning up YouTube, Twitter broadcasts, LinkedIn, and a few other channels. So please bear with us. We are still getting it started. We will start the real part of the webinar just in a few minutes once everyone joins. And yeah, we already have a few watchers who joined us online. Hello. So just to quickly explain how it runs, so you can ask any questions, for example, using LinkedIn or any other platform. We will see it on our dashboard. We will be answering them live. I will be helping Bas with all kinds of logistics. And Bas, what's your preference? Do you prefer to answer questions live, or do you prefer to get them answered after some time?
No, live is fine. Live is absolutely fine.
Mm-hmm. Okay. Then I think we can go live. So thanks again, everyone, for joining us. My name is Oleg Nashev. I'm a developer advocate helping with WireMock community. As I said, we are starting a series of WireMock webinars to talk about anything WireMock and WireMock Cloud, including development, API integration, testing, all the features WireMock has, like proxying, recording, and development too. So it's a kind of a WireMock themed webinar about everything for developers. And I would like to thank Bas for joining us for the first ever session. So Bas will talk about WireMock extensions. And yeah, would you like to introduce yourself?
Yeah, sure. And first of all, thank you, Oleg, for having me, and the rest of the WireMock team too. I'm really excited for this session, and it's an honor to be the very first guest on the very first WireMock webinar. So I really appreciate that. And also, of course, to everybody's online listening to this session, thank you very much for taking time out of your day. Yeah, the very brief introduction about myself. I don't like to talk about myself too much, but I'm Bas. I'm a test automation consultant and trainer from the Netherlands. I've been in testing and automation for 17 years now. I do consulting, training. I'll have some links to my presence on the internet all the way at the end of the slide deck, so you'll see that, so you know where to catch me. With my name, I should be pretty easy to find anyway. Yeah, and I've been in touch with the WireMock team, and most specifically with Tom, for a couple of years now. I've used WireMock pretty extensively, both with clients that I work with, as well as in my training courses, whenever I needed an API that did not go down when I ran a workshop. WireMock's that's a great use case for WireMock as well. Other than doing your actual testing, it's a great way to make sure that if you run an API testing workshop, you actually have an API to test. So what I'll be talking about today is WireMock extensions, and let me start by sharing my screen so you can actually see what it is I'm looking at and what I'm talking about. There we go. Okay, just very, very quickly confirm me that you can see my presentation now.
Yeah, it should be shared on the stream. At least I see it on the LinkedIn.
Awesome. So yeah, and again, if there's any questions, comments, regards, remarks, just interrupt me. I'm used to that. That's the way I'd like to work best. Let's try and keep this as interactive as we can. So I want to talk today about API mocking with WireMock, and specifically about upgrading your API mocks with WireMock extensions. So as I said, I've used WireMock a lot of times in the past, both in actual client projects where there was some kind of third-party system or API that was not really in our full control, or that we just wanted to isolate from the components and the services that we were actually testing. So this, for those of you who are familiar with WireMock, you probably know that that's the number one use case for using WireMock. To mock out the behavior of APIs or components or services that you either don't want to involve in your test, or that you do want to involve in your test, but that you cannot control well enough. So the behavior of the actual API that you want to interact with is unpredictable, it's hard to control, it's hard to set it up in a way that it behaves exactly like you need it in your tests. In all of these cases, WireMock can be a great help. The way I typically, well, I'm not in the business of selling tools or selling services, but in the way I advocate for using API mocking, API stubbing, service virtualization, whatever you want to call it, is these three benefits. I want to use API mocking, for example, with tools like WireMock, to either test earlier, test more, or test more often. Testing earlier is because and there will be many cases, especially when systems are developed in parallel across different teams, maybe even different organizations, where Team A wants to start testing against a service that's developed by Team B, but they cannot. Team B is still working on it, is still busy developing that service. With mocks, Team A can start testing early as long as they know what the service that's been provided by Team B looks like. You can build a mock that behaves exactly like you want it to and start testing earlier as being Team A. Testing more is probably my main use case for using mocks or stubs or service virtualization. It allows me to test those cases that are really hard, if not impossible, to simulate with actual systems. So, for example, if I'm building a web store that has an integration with a third-party payment provider, which a lot of web shops will have, and I want to test how my web shop behaves in those cases where the payment provider has an outage or is just slow, so it takes a long time to process the payments. That kind of behavior is often very hard to trigger with an actual test version of the third-party payment provider, because that service is typically, and the test environment of that service is typically way outside of your control. But by mocking that, you regain full control over the behavior of that now simulated payment provider, which allows you to, for example, easily test what happens if that payment provider returns an HTTP 500, so an internal server error, or it returns a response, but only after maybe even a couple of minutes. And that those are things that you want to test because you want to test the resiliency of your own application against that unpredictable, unexpected behavior of these components. But it's really hard to trigger when you actually want to test. And so you can test more with mocks than you hypothetically can with actual systems. And the last one is testing more often. This is there's a couple of different examples that I can use to illustrate that testing more often. For example, is if I'm testing against the mainframe, I want to do some kind of continuous testing where I deploy to production 10 times a day. But I'm testing against the mainframe that's only accessible every other Tuesday between 3 and 5 p.m. It's going to be really hard for me to do all the testing that I want to do every time, each of those 10 times that I want to go to production every day, especially when it's not a Tuesday. So mocks can help out a lot there as well. Another example is from a previous project of mine where we had our telecommunications order processing and providing system had a dependency outside of our own control, where we needed to be injected. Some data needed to be injected there related to addresses, if I remember correctly, and there was only one person there who could do that every other week. Which means that every test cycle took 2 weeks. And with mocking, we were able to bring that down to just a minute or two, which, as you can probably imagine, is a massive, massive gain. So there are many tools out there that can help you do this. WireMock is a great example of this. As you probably know, especially for those of you who've been using WireMock regularly, it's open source. It has both a Java API. You can configure the behavior with JSON mapping. So there's loads and loads and loads of features in the tool. And it's all open source. It's all free for you to use, to extend, to contribute to, which maybe Oleg wants to talk a little bit more about after I finish talking. So it's definitely one of my favorite solutions to actually make these things that you see on the screen right now happen. And what I like about WireMock is that out of the box, it can already do many things. So Oleg in his introduction just mentioned a couple of them. So you can use it as a proxy. You can do record and playback with WireMock. You have lots and lots of options to create dynamic behavior in your mocks. It does fault simulation, delays, all these things. It's pretty good at response templating, all those kinds of things. So out of the box, there's loads and loads of things that WireMock can already do for you. But it cannot do everything. Obviously, there's no tool that can do everything. And this is where extensions can come in very useful. So Tom and the other developers have been working on WireMock. They thought it would be a great idea, and I wholeheartedly agree with that, it would be nice to have some points in the WireMock architecture where you can actually extend the functionality, where you can extend the behavior of WireMock itself and of the mocks that you are going to write using WireMock. And that's what I want to talk to you about today. And I'm not just going to talk about that. I'm actually going to demonstrate them. So I've identified 4 different ways of extending WireMock. Well, 5 depending on how you count. And I want to do a bit of an explanation and a background, give you some examples on where and how to use those extensions. And I want to actually give you a live working example of those extensions as well, together with some tests, so we can actually see the behavior of these extensions in action. But before we begin, and before I start diving into the code and into the behavior of those extensions, I do want to give you to lead out with a word of caution, really. And that's because I've made that mistake in the past, and I've seen plenty of other people make that mistake in the past as well. Also, this is something that popped into my head just the other day when I had a browse through the WireMock Slack channel, which, by the way, is also a great resource to get into touch with the WireMock community, the people behind WireMock. So I'm sure Oleg will tell you something about that at the end as well, how to join that. But I was also I'm not very active on there, but I read a lot of the question on there, and where I can, I'll try to help. But I sometimes get the idea that people are trying to recreate an entire system through WireMock. And at least if you'd ask me, I don't think that's a really good idea. So what I sometimes try, or I get the feeling that people try and do, is re-implement the entire system that they're trying to simulate using WireMock. And these extensions are a prime example. Using these extensions, you can do so many things to further enrich the behavior of WireMock itself and of the mocks that you're building using WireMock. It's very tempting to say, well, in this sub case where this happens in my real system, it sometimes happens. So you want to, it's tempting to try and emulate the behavior of the actual system as closely as possible. And to some extent, that's a really good idea, but there are limits to that. If you'd ask me, as I was, first of all, keep it simple. And I know keeping it simple is actually pretty difficult. But I really want to say that keep it simple and really think before you start using these extensions, before you start trying to model, add super edge cases and really intricate, complex behavior of your actual system in a tool like WireMock. Do I really need this? Do I really need all of the very, very rich behavior that I'm actually trying to simulate? Do I really need that to do my testing? Because what you're essentially doing is, again, building a replica of the system, which I don't think is always the best idea. So that's my little word of caution before I dive into these extensions. It's, well, be careful, have a good think about, is this really something I need? Is this really something I want? Is this really something that's actually going to benefit my testing and my development? Before you start, again, rebuilding the entire system, basically just ending up with a shadow copy of your system in WireMock that you then also need to maintain and maybe even write tests for your mocks, and because it's so complex. And so I want to be a little bit cautious there. Having said that, all the putting the disclaimers aside, I want to talk to you about 4 different extension points for WireMock today, and I've prepared a demonstration for each of these 4. And they are request filtering, custom request matchers, post-serve actions, and response or response definition transformers. Let's start with request filtering. So request filtering is a great way, a very effective way. I think this is probably my favorite of the 4 types of extensions, because I can think of so many use cases for it. And also because using this correctly makes building out a lot of the other stubs and mocks behavior in WireMock much simpler. Request filters are a way, it's all in the name. They are classes, filters for your requests, which means that all of the requests that come into the wire, that arrive at the WireMock server, are first filtered, pulled through that filter, checked for specific properties, and if they meet those properties, then, or not meet those properties, then either you can tell WireMock to just to continue the processing and see if there's an actual mapping definition, an actual stub definition for that incoming request, or you can stop processing altogether and just return a predefined response. There's a couple of use cases for this, and I'm going to show you a demo of the first one, checking authentication details. You can also use it to inject some kind of dynamically inject some kind of headers, or maybe even rewrite the URL if that's needed, if you want WireMock to do that for you. But I think one of the most powerful use cases is checking every incoming request on specific details. And one prime example of that is authentication details. But these could be other types of request headers, cookies, specific elements with specific values in the request body, specific parts of a request endpoint, of the endpoint. But authentication details are a very, very good example of how to use that. The way to create a request filter extension, like similar the way to create every type of extension, is what you do is you extend one of the predefined extension points, really. So let's have a look at what that looks like. So I've got a little project here. By the way, all of the code that you see on the screen today, you can find that on GitHub. I'll show you the link to the repository at the end of the session. So by all means, do have a look at it. Download the repo, clone the repo, run the tests that I wrote to demonstrate the behavior on your own machine to get a really good feeling about, well, what do these extensions look like, and how can I use them in my own projects? The request filter extension that I built looks like this. So as you see, as I saw on the slides as well, I wrote a basic authentication request filter, and I tell WireMock that this is a request filter by making it a child class of the stub request filter class. This is a built-in class that's a class that's built into WireMock. This is my own basic authentication request filter. And what I need to do is I need to override two of the methods from the stub request filter class to define the behavior that I want to apply when I use this request filter. And in this case, the most important one is overriding the filter method here, which by definition returns a request filter action, and it takes the incoming request as an argument so that you can actually inspect it and see, well, I need this property of my request, I want it to conform to this, and then I want to do some kind of action. So this is just an example of what you can do with this. So what I'm looking for is the authorization header, which is still a name I struggle with because these are actually authentication details, not authorization details, but whatever. That's HTTP for you. So I extract the value of the authorization header, take the first value from that, and I check that the value is equal to some kind of valid authentication here. There you go. I'm screwing up already myself as well. Authentication details. By the way, if you want to, so let me know base64 decode, just so you know what it's actually saying is it's actually the username is equal to username and the password is equal to password. This also shows you how super insecure base64 actually is, and basic authentication actually is without SSL or HTTPS. So what I'm basically checking is if the credentials supplied by the consumer, so the party that issued the request, if the credentials match the username and the password, in that case, I tell WireMock to just continue processing the request. So, and I do that using the continue with method. And this basically tells WireMock this request passed the filter, so you can continue and try to find an actual stub mapping for it. And in all other cases, I tell WireMock, don't even bother trying to look for a mapping for it. Just stop processing and return a predefined response definition, which in this case is not authorized, which is, if I'm not mistaken, HTTP 401. I sometimes get confused about different HTTP status codes. So this is the definition of my filter. For all incoming requests, I'm going to check, does it contain the required authentication details? If so, then you can continue. If not, I just want to return a 401. Because that's what the system or the service that I'm simulating is going to do anyway. And by implementing this in a filter, I don't need to specify this for every incoming response for every response definition in WireMock, and I don't need to specify that for every endpoint that I want to simulate. I can just add this extension, this request filter, as an extension to WireMock when I start WireMock, and it will apply that to all the incoming requests. So let's have a look at a corresponding test that I built. So this is where I start WireMock. So I'll say I want to create a new instance of WireMock running on port 9876. And I want to load the basic auth request filter extension when I start my WireMock instance. So again, these extensions are something that you load when you start WireMock, and then the extensions will automatically, unless you explicitly tell it WireMock not to do that, automatically be applied to all incoming requests. And just to demonstrate to you how this works, I built a couple of tests here. This is where my actual mock definition is. So I'm also adding a regular mock a response definition here for those requests that do pass the basic auth request filter. I say, well, then in that case, if I have an HTTP GET and the endpoint is equal to this, I return a 200 and a body that's equal to authorized. Just as an example, just to show you what happens when the request actually, incoming request actually passes through the filter. So I've got two tests here. One where and by the way, I'm doing this using Rest Assured. For those of you not familiar with Rest Assured, it's a wrapper. It's a very popular Java HTTP API testing tool. It's a wrapper around the built-in Java.NET HTTP client, and it makes testing fun and readable again, at least if you'd ask me. So what I'm saying is create a request with these credentials and do an HTTP GET to that endpoint that I defined here, and check that the status code is equal to 200 and that the body is equal to authorized. So if I run that test, Rest Assured will add that I've made sure here that my WireMock instance is called at port 9876, and I tell rest assured to also send that request to 9876. My test passes, which means that the request that I'm sending here goes to WireMock, passes through the basic authentication request filter, and WireMock actually looks at its collection of stub mappings, which is only one right now, and responds through by means of this response definition. The other test shows you what happens if I send the request with incorrect credentials, just to show you the behavior that we defined in this request filter here, because we said, well, if the credentials are not equal to this, and by the way, rest assured we'll take care of converting these credentials to their base 64 encoded counterpart, their version. So if I pass in incorrect credentials here by changing the password to something that's not correct, in those cases, because that request will not pass through this filter because, well, the credentials are incorrect, so it doesn't meet this condition. I've told WireMock to doesn't matter what the rest of the request looks like, always respond with an HTTP 401, which is exactly what I expect here. So if I run this test, you can see that it passes as well, meaning that the request filter, the basic authentication request filter, that's exactly what we wanted to do. So with only a single response definition in WireMock here, I've created a mock for both these situations, for the situation for the case where there's correct credentials and for the case where there's incorrect credentials. And the good thing is, the beauty, I think, about these request filters is that because you apply them at the WireMock instance level, it's automatically applied to each and every request that arrives at the WireMock server, and without you having to explicitly define that.
Yeah. So while we are here, there is a few questions that we could answer right away. So
Please
the
do.
first one is actually, can you add multiple extensions at the same time?
Yes, you can. My examples do not do that because I like to keep my examples pretty small, because that's easier to explain. But you can, I don't know if there's an actual limit to it, but you can definitely, well, as you can see from the definition, from the ellipsis after the extension, you can add, I think, as many extensions as your system memory allows you to a WireMock instance.
Yeah, that's right. There is no strict limitation for that. I will skip one question to return to it in a few seconds. So another one about limitations and bandwidth is a number of incoming requests.
The number of incoming requests.
Yeah, and whether they can be parallel.
I think you're in a better position to answer that question, Oleg, than I am. So
okay,
please, if you want to take that, please do.
Okay, so speaking of WireMock, it actually has multiple modes of execution. So one, what Bas presented today, is within unit tests. It can, in this case, it runs basically within the same JVM as your test. It provisions an HTTP server, which has embedded a JT server for processing requests. So it will be still emulating network processing. And yes, you can submit multiple requests, including parallel ones. The thing is, what you are going to get there, it basically depends on you, because there is higher risk of overloading your server, especially if you run your JUnit in multiple threads, because it will mean that there are multiple WireMock servers serving multiple requests. So there is certainly a limit, but basically depends on your system throughput. In principle, WireMock doesn't set limitations. What you need to keep in mind that there is some modes of WireMock behavior. For example, it allows doing stateful behavior. So when you receive one request, and based on that, WireMock changes the state. So for this type of requests, concurrency is, of course, need to be done very carefully. And if there is interest, we can review such requests later. Another question that we got is about WireMock standalone. So basically, the question is whether you can do the same using extensions with standalone WireMock instance.
Yes, you can. And again, Oleg, please feel free to interrupt me, because you actually know, I know the product quite well, but you definitely know it better than I do. But yes, you can. So you need to define your extensions in code, but you can load them from the command line as well. So you can load them on top of your standalone WireMock instance as well.
Yeah, that's right. So let me show the documentation for a second.
Yeah, if you want to take over screen sharing for a bit, just let me know.
I think it should be okay. Just a second. I'll just... okay. Now you should see my screen on the stream. At least I believe so.
I do.
Okay. Then everyone should see that. So if you go to the WireMock website, we did some updates to it. But there you can also see references to WireMock standalone in both standalone jar and Docker. And if you go there, actually you can find some tips about how to run extensions there. So long story short, an extension needs to be in the class path, which can be used defined via standard Java arguments. And after that, you need to pass extensions parameter that basically defines the class of extension to be loaded. So you can see the example here. If you use WireMock Docker, it's actually a bit more simple because we have a predefined class path there. So for Docker running with extensions, you can see that there is a directory var WireMock extensions. And you need to put jar files there. And once you put them, you just pass a class path, and the extension is loaded. I was about discussing the upcoming bits a bit later, but we want to actually improve the extension mechanism so that there is some bits of lazy loading, dependency injection. So this is something we can discuss after the main presentation, because there are multiple ways how the current extension handling could be improved.
Thanks so much, Oleg, for that interlude. I really appreciate it, and I'm pretty sure that the people who are in the room do as well. Because, well, again, there are definitely parts of the project that you just know better than I do. So I'm more than happy to hand those over to you. Awesome. Can you make sure that people can see my screen again? Because
Yep.
There we go. Awesome. So that was the request filter extension. The second one that I want to show is custom request matchers. So as you probably know, for those of you who've been using WireMock, request matching, well, for those of you new to WireMock, is basically the strategy that WireMock uses to determine if it's going to respond to an incoming request and how it's going to respond to it. And so it's basically what kind of characteristics what kind of properties of the incoming request am I going to look at to determine whether or not I'm going to send back a response. And again, out of the box, WireMock has a lot of useful requests. So it can look at, and this is not a complete list, but it can look at HTTP method to the endpoint, so the path or sections of the path. It can look at request headers and their values. It can look at request body elements and their values. It can look at cookies. And there's all kinds of sophisticated matching logic possible there. So, for example, you can do Boolean logic with, if you want to combine multiple conditions, you can do all kinds of interesting stuff and very useful, powerful stuff with dates and date offsets. So it's pretty flexible, and there you can do a lot of pretty rich request matching already. But for those cases where the built-in request matchers just aren't enough, you can also build your own request matching logic. Maybe the best thing about this is that it's not either or. So you don't need to either use the built-in request matchers or your own custom built ones. So there's no need to recreate existing request matching logic, but you can combine them. So if you want to look at multiple different properties of the incoming request, and some of them are covered by the built-in WireMock matchers and other ones you need to build for yourself, you can do that. Again, you do this by extending a built-in WireMock class, and that's in this case actually the request matcher extension class. So the concept is very similar to what we just saw with the request filters. So there we go. But it's slightly different. So in this case, I extend to build my own custom request matcher extension. I extend the request matcher extension that's built into WireMock, and in this case, I'm building my own matcher that just as a demonstration that looks at the content type header of the incoming request. The nice thing about this is that you can parameterize it, so you just don't just take the incoming request, but you can also add a set of parameters to make it even more flexible. So where this request filter only looked at the incoming is a little bit more static, the matching logic, you can feed parameters to that as well. So what this returns, this is again the important method. This is where you actually implement the matching logic, the matching behavior. So this reads the value of the content type parameter from the parameters that you pass into this matcher, and it returns whether or not the actual content type header of the request contains. So it could also be is equal to or not equal to or whatever. That's all logic that's supported. But I'm checking that, this is, for example, useful where if I don't really care whether or not the content type header is text XML or application XML or any of the other MIME types that contains XML. The only thing I care about is that it's an XML, it's a MIME type that supports XML. I could then use this matcher to do that and pass in a parameter value, a parameter content type with the value XML, which means that it'll match, again, application XML, text XML, and I don't know which, with that there are probably more than those two, but it matches all of the MIME types that contain XML. And again, this match result is just the result of it. That tells WireMock, well, the incoming request matches these conditions that you defined in this method, or it doesn't. Looking at how I use that is, again, I create a new WireMock instance here and load my extension. You can do that, but even in code. So Oleg already showed you a lot of different ways to load extensions into your WireMock instance. Even if you do it in code, there's, I think, and please correct me if I'm wrong, 3 different ways of doing that. You can either do it by creating a new instance, like what I do here, which is what I'm used to do. You can point to the qualified name of the class, and you can just point to the class name. I think those are the 3 options there. So use whatever you like. I typically just create a new instance because I think that's the most natural way of doing this. Also, that doesn't leave me with some kind of big string that can contain typos. And if I type it, there's bound to be typos. So I'd rather just use IntelliJ or whatever IDE you're using to help me actually provide me with the right class name. This is where I write my mock definition. I say, well, I stop for a request that this is where I pass in my custom request behavior, my custom request matcher behavior. Sorry. This request matching method, I can use this to say, well, I want to use the logic that's defined in this matcher, which is the result of the return value of this method. So it's called content type matcher. That's the name that uniquely identifies this custom request matcher extension. And I say I want to pass in a set of parameters. In this case, it's just a single parameter. And the parameter name is content type, and the value is equal to JSON, which tells WireMock to apply that custom matching logic. So in this case, you need to you apply that to individual. In this case, I apply this to an individual response. There's probably also a way to apply this to all responses that you do, but maybe Oleg can fill you in on that in a moment. But in this case, I apply this to one specific response definition. And I tell this to check that to only match if the content type header value is equal to application JSON. Please keep in mind, this is just an example. Of course, there's another way to do this as well, but this is just to demonstrate what a custom request matcher, how to use a custom request matcher really. And again, I've got some tests here where I say, in this case, I pass in the JSON content type, which is application/JSON. So this will match. So there's a match for this, which means that it's going to return this response. And of course, it's going to do that because I tested my tests, but just to show you anyway. And so this request that's being sent by Rest Assured will pass through this custom matching logic. It's going to be a match because my request header, the content type request header is going to be equal to application JSON because that's the value of this enumeration. So there's a match, which means that the status code and the response body will actually be equal to this because WireMock sends a response. And if I use XML, for example, it's not going to return. It's not going to be a match, which means that WireMock will fall back to its default response, which is an HTTP 404. And because there is no match, because XML is just not equal to JSON. If I would have said, if I would change this to XML, this one is going to fail because the stat. I don't want to debug, I just want to run it. Stop. Go away. Just run the test. This is going to fail because it actually matches, so it's going to return a 200 instead of a 404. There you go. And because now there's a match here, which means that WireMock actually does have a response definition for this with a 200, which makes my test fail because it expected a 404, but it's not. It's not returning a 404. So this is how to define custom matching logic. So you can, I think the WireMock website shows you an example where you can quickly say, well, I want to check on the size of the request body. So for example, I want to check if the request body contains at least X number of bytes. If so, I want to send back this response. If not, I want to send back a different response. So those are all things you can do with this custom matching logic. So you can build pretty intricate things here. So you can make this as complex as possible. But again, please keep in mind that warning that I gave you just earlier. Any questions, Oleg? And I see, well, time is flying actually. So I didn't expect to be speaking for this long, but I still got 2 more to go.
Well, we're quite informal, so if you need more time, it's not a problem at all. Yeah, there is a quick question about explaining step 4, but I think you just covered it a few seconds ago, or why we actually need it.
So you mean this?
Yes.
This is how you add response definitions to WireMock. This is how you tell WireMock to return specific responses in case it receives incoming requests that match certain properties, really. So this is one way to do it. So again, I'm writing all my mock definitions in Java, which is where these stub 4. And I think there's an alias method for this. I think it's called given, but I'm not sure. I always use stub 4 because otherwise it gets me confused with this given. This is the rest assured given. But I think there's a... Oh, given that. Okay, so not entirely confusing, just almost confusing. But this is where you define, well, if there's, and again, you could combine this with built-in matchers. So maybe you say, I also want to check on the HTTP method, for example, which is what I don't do here. You could, for example, say, well, I want to combine that with, I want to check on both the HTTP method, which is done by using a built-in WireMock matcher, and then I want to use my own custom matcher as well to because I want to check for several different properties of my incoming requests before I decide to return back a specific response. I hope that answers the question well enough. If not, just let us know.
Thank you.
The third one is post-serve actions. this is, I like explain this as basically doing a great way to do reporting and logging and housekeeping. Every time WireMock returns a specific kind of response, or returns a response in general. So I don't think there's a lot of post-serving built into WireMock, but in case you say, well, I want to maybe keep track of all the responses that or all the incoming requests that are processed by WireMock, and I want to keep track of which ones are matched, which ones are not matched, how long it took WireMock, what the matching result was, properties of the incoming requests, all those kinds of things. You can do that using post-serve actions. I'm going to go through the other two ones a little bit more quickly because, again, the principle is the same. Hey, you extend the class, you define the behavior, and you load the extension into WireMock. So I've got an extension here that is, well, admittedly, simple, pretty straightforward. So I have a write to database here, and my database is, in this case, just the console, so not an actual database because I was too lazy. But what you do here, so you extend the post-serve action method class in WireMock, and I create my own action, and I override both the getName method and the actual do action, which is where the magic happens. That takes 3 arguments. Again, it can take parameters. In all honesty, I don't exactly know what this thing does, but the serve event contains all the information that WireMock has about the request, about the event, about the actual result, about the matching, which is what I add. And this is just an example of what I'm logging here. So just to show you that you can do stuff with the parameters. And I print some info about the actual the serving of the response by WireMock, basically. So I'm using 2 properties here. So a get was matched, which means was WireMock able to return a response for this incoming request? Was there a match in the stub definitions that in WireMock? And how long did it take WireMock in total to return that? Again, I have a post-serve action test where I spin up my WireMock instance with that post-serve action, and I define the actual behavior of that post-serve action here for this specific response definition. I say, well, I use the write to database, post-serve actions, and I parameterize that. I pass in that this is my database as the name for the database. And if I run this test, it's already running. You'll see that WireMock says, well, this is what it's doing because this is the event that I pulled the parameter or the database name from the parameters, and it also contains some logging about was that a match? Yes, there was a match in this case. So WireMock recognized the incoming request and was able to serve to return a predefined response, and that took 60 milliseconds. And there's loads of other properties that you could find here as well. So if it was complete, the ID, which I think is a WireMock internal ID. You can get the actual request and the response to log that to, maybe you write that to an actual database or something like that. The response definition with the stub mapping, and there's all kinds of properties there. So there's loads of info in here that you can extract and use in whichever way you want to use that. This is just, again, a very simple demo, but the magic will actually, if you say, well, I want to log this to an actual, I don't know, an event stream or a database or whatever data source it is that you're using, this is the way to do it, using post-serve actions. Any questions about that, Oleg, in the meantime?
There is one question which is not strictly related, is whether we could emulate WebSockets using WireMock.
Can we, Oleg?
Well, so there are two answers. So first of all, if you write a proper extension, of course you could, because how WireMock operates, it actually allows different receivers as a part of extensions. And there are a few good examples. For example, gRPC extension written in Kotlin. Also, I'm currently doing one for cloud events. And if someone wants, of course, it's possible to do WebSockets. It's even there is even a feature request for that. But right now there is no implementation. I need to double check, because if you look on GitHub, most likely you will see something. But I don't think there is one that I would be ready to recommend as ready to go implementation. But if you create a feature request for that, if you're interested to write an extension, of course, it would be possible to implement one.
Yes, that's the power of open source.
Mm-hmm.
So thank you for that elaborate answer, Oleg. That's much better than the answer that I would have been able to give, which is I don't know. So it's good to have you here to actually take those questions that I cannot answer. I appreciate that. Any other ones before I go to the final class of extensions that I want to cover? It sounds like I didn't even cover, I'm not even going to cover them all, because you can also write extensions for different protocols and message formats, which is not a type of extension that I'm going to cover in this session, but now I have something to look into as well. The last one, the final one that I want to discuss, that I want to quickly demonstrate here, is response transformers and response definition transformers. And this, for me, is the most difficult one to explain. Don't ask me why, but I'm going to try and do this as best as I can. Response definition transformers allow you to create responses in a more dynamic, programmable, programmatic, reusable fashion. And it helps you to... so the default WireMock API, so the set of methods, allow you to of course, create responses where you say, well, I want my response to have this status codes and these headers and this response body. But there might be a lot of situations, a lot of cases where that's going to be very, very repetitive. And that you can address, for example, using response transformers or response definition transformers, where you want to say, well, all of the responses that are returned by WireMock whenever there's a match need to have these properties. For example, a very simple example, I want to add a specific response header to all of the responses that are successfully returned by WireMock. So The tedious way to do that is by just adding that header definition to all of these responses, to all of these response definitions. The more intelligent way and also the more maintainable way to do that is by using a response transformation extension or response definition transformation exception. Let's have a look at exactly that, at just that example. No, let's this one first. So the end result is both the difference between a response transformer and a response definition transformer is that one of them, so the response definition transformer is applied to the response before it's actually generated by WireMock, and the response transformer is added at the end. So the biggest difference is when are these transformers applied to the response? Before or after WireMock actually applies all the methods that you have in your stub4 method to the response. Maybe not the most sophisticated of answers, but I'm pretty sure that it's correct. If not, by all means interrupt me, Oleg, or correct me after I do these. But again, what you can use this for is, again, a much more powerful generic, just define once, use everywhere, or use in a lot of different places for specific parts or even entire responses. So my definition transformer, response definition transformer here extends this class. And what I override is the transform method. So I build a new response definition here, which is just a template, definition that WireMock uses to create actual responses. And what I say is, for each of the responses, I'm going to add that. I'm going to send with the WireMock instance where this transformer is loaded. I'm going to set the status to 200, and I'm going to inject a current date header that actually contains the current date and time in a specific format. So again, this one also takes parameters. And so, for example, I can specify a custom date and time format here. The response transformer does something very similar, but it's applied to the response after it is rendered by WireMock. You say, well, and so in this case, if I say I don't want to so I use the response that's being rendered by WireMock, but the headers, the actual set of headers that WireMock will actually return is the original set of headers. So this is very important to preserve the headers that you define in the individual stub definitions. But I'm going to add another HTTP to header, which is the same thing. So the end result here would be the same. The biggest difference is, am I going to apply this before or after WireMock renders the actual response? And in this case, you can also set a flag for this extension to apply it globally, or require the user to apply it for each individual stub for a response definition. That's the word I was looking for. Here too, I have an example. So again, let me start actually with the definition transformer, which this returns. So there's no actual response properties in here because these are all set in here. So this is just a single place to define the response status code for all response definitions that use, let me just close these ones to not confuse myself and you, that use this transformer. And so did this uses the response definition transformer. It supplies the date format, and I make sure here that the current date actually is equal to the current date in this same format, which is just proof that WireMock applied this response definition transformer. So a definition, an extension that adds some properties and that can potentially add properties to lots of different responses and all defined in a single place. So I've got a status code 200 and an current and an injected current date header with a specific format. I check on both of those properties here just to make sure that the response definition transformer actually adds them both to the response, which is what it does. And just to quickly show you what the other one does is that this is the transformer again, so it preserves the original headers, which are, for example, this one. And so I just included this one as proof in the status in the individual response definition, just to show you that it should preserve this one, because I say, well, I need the headers from the original response definition and I want to add one to this. I don't want to overwrite them. I want to add another header to this one. So I'm checking here on two different headers. One that's preserved, that's from the individual response definition, and the other one that's added by the transformer. And as you can see, after this test has run, is that it passes, which means that the header from the individual stub definition is preserved, and the header that's not defined here, but that's actually defined in the transformer, and that's added to the response by WireMock in the transformer, is also present in the actual response that Rest Assured observes. So this again, these response transformers and response definition transformers are great to define common characteristics of responses. So if you have a lot of responses that all need the same header, maybe even the same status code or response body elements, you could do it the tedious way and then add them to all these individual response definitions, or you could use either a response transformer or a response definition transformer and just define it in a single place and then let that extension apply that extension to all of the responses and have WireMock do the heavy lifting for you there. That is what I wanted to cover, what I want to demonstrate in the session today. Oleg, you already showed this link.
Yes, but I definitely won't hesitate to put it again.
Yes. So first of all, I already really like the WireMock documentation, but I know you and some others have been working really hard on the docs in the last couple of months. And I just want to take the opportunity here to again say how much people like myself appreciate that. Because good documentation is super important. And WireMock, I am not a WireMock employee. They don't pay me to say this. but I really like the documentation. So that includes the documentation on how to extend WireMock. There's some more examples in that as well.
Thanks a lot for your feedback. And for the record, all the documentation is open for contributions.
Yes.
And just submit a pull request. On any page, if you scroll down, there is a small link called Improve this page. And if you click it, magic happens and you'll open it in the GitHub interface.
Does magic actually happen?
Well, unless I broke something recently.
No, I just wanted to show you because I'll just say stubbing. And if I go all the way down here, there's improve this page and you'll be taken to the right. It's all marked down, so it's straightforward and very rich. And that's where you that's how you improve this page. So if you see a concept, by all means do that. What I just want to say is, if you want to have a look at my code, review the examples that I showed you in this session. It's on GitHub, so by all means do. I'll take pull requests on that too. I don't know if there's a lot of point in that. If you have to make a choice where to spend your valuable time, I'd say improve that spend it on the WireMock documentation and not on my examples. Unless you have some some feedback for me or other examples, I'd love to see that. And that's it from me. So a final call to you, Oleg, if there are any outstanding questions.
Yes, we have one question, and there is still a few minutes to ask them. So the question is, can you control the order of extensions being executed?
I don't know, but maybe you do.
Well, I do. So the answer, there are two answers. One answer, in principle you can, because there is just ordered list. So once you register the extension, they will be executed exactly in the same order. So firstly, it loads extensions from ClassPass and from CLI. Then if you operate, for example, in unit test, it also adds extensions defined in the unit test on the top of it. Whether this behavior is documented, no. And whether this behavior can change in WireMock 3 or later, yes, it can. This is why, actually, I already shared a link in the chat. There is a ticket for reconsidering how the extensions engine works in WireMock, and things like explicit ordering of the extensions is something that should be definitely discussed there. Fortunately, we don't have so many cases when ordering really matters. But in principle, yes, I can imagine a case, for example, for stream processing of data, where it can be important.
Yes. Wouldn't it be, and this is just me asking a very naive question, wouldn't it be just a bit of a smell if you have situations where just like if I did so, I know quite a bit about API mocking. I know even more about testing and automation. So having to rely on specific orders of execution in my tests is definitely a smell and an anti-pattern. Don't you? And this is just an honest question from me to you, Oleg, is would you say it's similar for this case, for WireMock extension? So if you have situations where you absolutely rely on extensions being loaded and applied in a specific order, you probably need to simplify your stub, to refactor or simplify your stub definitions.
Yeah, I would rather agree with that. So I can probably come up with some edge keys when it's actually needed.
Yes, the problem with these smells is that immediately there's going to be people who's going to say, well, but in my case, let me show you my example, or let me give you my situation. be pragmatic about it. I would say that's what I tend to be pragmatic and try to make things as simple as possible. And the simpler you make it, the lower the risk is that you actually have to depend on stuff like this about order of execution, for example. That's just a general piece of advice for me. Take it, leave it, whatever.
I had to post it, but yeah, in principle, there are some use cases. What you need to be careful about extensions so that there are actually different types. Some extensions are not compatible by design. So, for example, there is a ticket for externalizing storage, and obviously there could be only one extension that implements storage for WireMock, or maybe not. But this is how it's seen at the moment. So eventually something will be needed to make a more sophisticated extension engine. I actually come from the Jenkins open source project, so be sure I have no doubt about the importance of extensions. And also I'm internally horrified about the perspectives of having 2000 extensions in WireMock.
Oh, please don't make it as complicated as Jenkins with all the extensions.
Yeah, so we will be careful about that. But yeah, currently the trend is that a lot of complex functionality. So for example, now there is ongoing work for GraphQL mocking. So Kapish, one of contributors to WireMock, is working on that. And the idea is to keep such complex functionality as extensions so that the WireMock core is relatively independent from everything.
And will those be, I'm just going to turn the presentation around. I'm going to ask you the questions now, Oleg. Are those extensions, is that in the planning to offer those extensions through some kind of marketplace?
Oh, that's a good question, because I can show what I started doing. First of all, yes, I can see the marketplace. But at the moment, the question is how many extensions we actually have, because right now it's not that many. No. And if there are too many, yes, we will introduce a marketplace. What I started from, do you see my screen already? Yes. So here, if you go to the documentation, I started putting the list of known extensions in the new solution pages we introduced. So, for example, it's probably not that obvious, but we have an entry for Java, which actually includes the listing of the current extensions that are stable and that are being used. And later I will move them to the separate documentation page. So whether you can call it a marketplace, no, but they will be a fancy page listing WireMock extensions. Similarly to what we already have, for example, for API templates library. So this is the feature we've just released recently. And here we have a listing of various templates that are ready to go and you can reuse. So probably we do the same with extensions. Mm-hmm. How it's done to be seen in the future, because there are multiple topics to think about. So for example, what do we do with other implementations? For example, WireMock Python, WireMock.NET, how we actually approach hosting of these extensions, because many of them are not going to be compatible with WireMock 3 or future versions, because there is a lot of ideas how we could improve things. And some ideas are, of course, breaking ones. But I hope that in the future we'll have stable documentation of extensions. And for things like, for example, WireMock Docker images or WireMock test containers models, we will also have an easy way to use these extensions without actually remembering all paths on GitHub or on Maven Central where to find them. So stay tuned.
Lots and lots of interesting things coming up in the future. So I really appreciate you giving a bit a peek, me and the other people on the session, a bit of a sneak peek into what's in store for the future. I'm going to wrap up here, at least from my side. The last thing that I want to show is just if you have some questions, some comments, some feedback, if you want to get in touch, stay in touch, whatever. Have a chat about anything we discussed today or anything that I do. Email works, LinkedIn works, and I've got a website too. So yeah, that's it for me. Again, Oleg, thank you so much for. I'm going to stop sharing now. Thank you so much for having me. I really appreciated it. I also appreciate we didn't rehearse this, but the dynamic and the going back and forth and
yeah. I prefer informal sessions without too much preparation, because we are not doing
I did. Maybe you couldn't tell, but I did actually prepare this. But no, I know what you mean. It's. I appreciate these informal conversations too. So
yeah,
thank you so much.
Thank you too. And maybe one last thing I wanted to mention for everyone. So first of all, yes, if you're interested, please join us on Slack. So it's just slack.wiremock.org, which you can find on our website too. Why it's important? Because again, we are growing the community. We are starting a lot of different initiatives, and there is a lot of collaboration implied here and there. So how to get there? If you go just to wiremock.org website, here Slack community, and basically it gets you to our community Slack. And if you want to know more about where WireMock is going, it's something that we will be announcing soon, but we actually already have a public roadmap. So if you go to our GitHub, there in projects, you can find a few interesting entries. So first, WireMock public roadmap, then also there is scope for WireMock 3.0, and for WireMock community and all kinds of community management things I'm working on. But yeah, for end users, this link is probably the only important one. And here you can see a lot of initiatives happening in WireMock in different stages. So if you're interested to know where the community is going, you can check it out. And there will be more and more views for different use cases. So for example, here's WireMock Java, and basically the scope for WireMock 3. So this is just a hint about what we will officially announce maybe this week, maybe next week. But yeah, there is a lot of things under the hood and a lot of things coming up.
Yeah, and if you, by the way, so I know because I've sort of got there's going to be a lot of changes in WireMock 3. I've not tried it out myself yet, but I know you've already released. I think you're on beta version 9 now.
Yep.
Yes. So just from me, it's so if you want to see what's happening, if you want to get involved there, if you want to have give some feedback on new WireMock versions, there are beta versions available. So I didn't want to risk using a beta version for this session yet. So what you saw was still WireMock 2.35. I think.
Yes, 2.35.
So, but there's lots of goodies happening and coming up in WireMock 3.
Yeah, and so we hope to release maybe in 1 month. No commitment at the moment. It's done when it's done. But we're definitely marching towards the final release with a bunch of enhancements and fixes. For the record, WireMock 3 is going to be largely compatible with WireMock 2. A few items that needs to be mentioned, that we are dropping support for Java 8. So if you use Java 8, you will have to switch, for example, for WireMock model for test containers, or maybe use WireMock 2 for now. But on the other hand, we are adding a bunch of new stuff there and also do a lot of optimizations. So the performance improvement of WireMock 3 is, from what I see on my GMH benchmark, is something like 30% on my stubs.
And is that resource consumption?
Well, it's mostly a processing time.
Processing time, okay.
Because the resource consumption really depends on how much memory you have. On my laptop, I have Slack, I have Zoom, so I don't have a memory for anything else.
Yeah, but that's what you get for using Slack and Zoom.
Yes.
Yeah.
Okay. So thanks a lot, Bas, for your presentation.
Thank you for having me.
Yeah, thanks for everyone who watched us live. We will be publishing all the videos. You're welcome to join our Slack channels to discuss. I'll also ask Bas to publish the presentation so that we can assemble everything together.
Yes.
And stay tuned for the next webinars. So hopefully we'll have another one in something like 2 weeks. And hopefully it will be about WireMock 3 and what's going inside.
Awesome. Thank you so much, everybody. Have a great day.
Okay. Thanks all. I'll end the broadcast.